this topic, we will discuss CPU scheduling algorithms, which are an important part of an operating system. The CPU is the most important component of a computer because it performs all the calculations and processing. However, in a system, there are usually many processes that want to use the CPU at the same time. Since the CPU can execute only one process at a time, the operating system decides which process gets the CPU and for how long. This decision-making process is called CPU scheduling, and the rules used to make these decisions are known as CPU scheduling algorithms. Why CPU scheduling is needed? CPU scheduling is needed to make the system efficient and responsive. If scheduling is not done properly, some processes may wait too long. The CPU may stay idle unnecessarily. System performance can become poor. Good CPU scheduling helps increase CPU utilization, reduce waiting time, improve response time, ensure fairness among processes. Key terms in CPU scheduling. Before discussing algorithms, it is important to understand some basic terms. Burst time, the time a process needs the CPU to complete execution. Waiting time, the total time a process spends waiting in the ready queue. Turnaround time, the total time taken from process arrival to completion. Response time, the time from when a request is made until the first response is produced. These metrics are used to evaluate how good a scheduling algorithm is. Types of CPU scheduling. CPU scheduling is mainly divided into two types. 1. Preemptive scheduling. In preemptive scheduling, a running process can be stopped and replaced by another process. This usually happens when a higher priority process arrives. 2. Non-preemptive scheduling. In non-preemptive scheduling, once a process starts executing, it runs until it finishes or blocks. The CPU is not taken away forcibly. First come, first serve, FCFS. First come, first serve is the simplest CPU scheduling algorithm. In FCFS, the process that arrives first gets the CPU first. Processes are executed in the order of arrival. Advantages: easy to understand and implement, no starvation since every process gets a turn. Disadvantages: can cause long waiting times, suffers from the convoy effect, where short processes wait behind long ones. FCFS is rarely used in modern systems because it is inefficient. Shortest job first, SJF. Shortest job first selects the process with the shortest burst time. There are two versions: non-preemptive SJF, preemptive SJF, also called shortest remaining time. First advantages: produces the minimum average waiting time, efficient for batch systems. Disadvantages: difficult to predict. Burst time, long processes may suffer from starvation. SJF is optimal in theory, but hard to implement practically. Priority scheduling. In priority scheduling, each process is assigned a priority number. The CPU is given to the process with the highest priority. Priority scheduling can be preemptive, non-preemptive. Advantages: important tasks are handled first, useful in real-time systems. Disadvantages: low priority processes may starve. Starvation can be solved using aging, where priority increases over time. Round-robin scheduling. Round-robin is one of the most widely used scheduling algorithms in time-sharing systems. In this method, each process is given a fixed time slice called a time quantum. After the time quantum expires, the process is moved to the end of the queue. Advantages: fair to all processes, good response time, prevents starvation. Disadvantages: too small time quantum causes frequent context switching. Too large time quantum behaves like FCFS. Choosing the right time quantum is very important. Conclusion: CPU scheduling algorithms play a critical role in operating systems. They decide how CPU time is shared among processes, directly affecting system performance and user experience. Different algorithms are suitable for different situations. FCFS is simple, SJF is efficient. Priority scheduling handles important tasks. Round robin ensures fairness. Multi-level feedback queues provide flexibility.